Hey guys, welcome to a new video on the Cell Doctor channel. I started soldering the wires for the Mega Cell charger, the professional version. I have almost 100 wires to solder on each board, so there is a lot of work. I got it to 25 minutes per board and I started from 45 minutes, so that's an improvement of almost 100%. But today's video, it's not about the Mega Cell charger. I want to show you how I build a 12-volt battery using lithium phosphate cells, 280 amp hour cells, and the battery case that I purchased, including all the wires and the BMS. So let's get to it. I'm going to remove the Mega Cell charger from the view for now. Alright, so this is how the battery case looks like. You can see it has a panel in the front. Also on the lid it has a display. I will show you later when we get to assemble it. It has two nice handles on the sides to lift the battery, and I'm going to show you the cells that we'll be using for this battery. They are huge 280 amp hour cells with a nominal voltage of 3.2 volts, and you can see that it almost has 900 watt hour of power in this big cell. It's quite heavy, but yeah, it should do the job. We'll have a 12-volt battery with 280 amp hour, and this should fit nicely in our case right here. Yeah, and it does. Alright, so let's first check that we have all the components. So the cells I have, they are 4 right here. And I want to see the rest of the components as well. This kit that I bought comes with everything you need to assemble this. So you see it's a 4S bar right here. It has the front connectors, the wires. It has bus bars for connecting the cells together, nuts, washers, and pretty much everything you need to get the job done. Some more screws, a thick cable right here, some isolation for the terminals, I chose to use a BMS as well for this, and it also comes with a button for powering the battery on. This is the JK BMS. It's a Chinese BMS, but it also comes with Bluetooth. You also have some communications for CAN, GPS, and all that. But we're not going to use communication for this battery. Alright, so I got everything I have in the box. I noticed that the kit does not come with any instructions, so it's going to be puzzling to get the job done. It also comes with these protection boards that will be placed between the cells so they don't short circuit, and also keeps them pressed properly when assembling them. Alright, so let's switch to top camera and let's begin assembling these. So we have 4 or actually 3 side panels So one should be for bottom and two for the sides. I also see that it has the double-sided tape, so we can choose to stick this to the cells or stick it to the sides, and I will stick this to the sides of the battery case. So I can put the cells one by one inside. I really like this double-sided tape because it's very thin. I should try to source something like this. I actually think that one of the boards is smaller than the others. Because the bottom one does not want to fit in properly, so I'm going to try to remove that. Alright, it's off. Yeah, you see this one fits in properly for the bottom. Placing that at the bottom and this one on the side. Alright, that does the three sides isolation, and I'm going to check for isolating this side as well. I have these panels. And they are not cut to size, so I need to trim them a bit so they fit. Alright, so I will start laying in the cells. I checked some videos about this box and I saw that they should be placed with the minus on the left side. I noticed that I have some extra space here and I would like to fill that with the remaining foam, because I don't want to have any wiggle room between these batteries, or have as little as possible. Okay, let me remove this. Alright, that's better. Double check that I have the spacers, and I do have them. And I will place some spacers. I will place spacers at the end as well. Alright, so we double check that we have the cells the right way, and in my case I do. And I can now start connecting the cells together. To obtain 12 volts, we need to connect these in a series. So it goes minus to plus, plus to minus, then again plus to minus, then plus to minus. I'll be using washers, but in this case you can see that it's 13 volts. So let's continue assembling the terminals of this battery. So this is for the positive one. The next thing is to assemble the balancing leads. Before screwing in the nuts for the batteries, I actually have to place the balancing leads. So I will do that right now. As a reference point, you can see that this connector goes in the front of the battery. I put in some screws. This goes here, but I will not tighten this yet. Alright, let's see. When tightening the nuts, I will keep with one hand the wire, the balancing wire in place, so it doesn't move around or stretch to the point that it gets ripped from the balancing board. Make sure not to over tighten these screws, because you can damage the cells, and these are quite expensive ones. Alright, so the BMS gets placed like this. And I have a bag with some black screws, and I will check to see which one will fit in there. Yeah, it's these smaller screws that will be used to hold on the BMS. If you're not familiar with the BMS, what this equipment does is monitoring the voltage on each cell, and make sure that they are not overcharging or over discharging, keeping the system in the right parameters, so the cells will not catch fire during charging or the discharging process. So this is a very important part of this assembly of this battery. When using lithium ion, make sure you're using a BMS. Otherwise, you're looking for problems. Okay, so now I can actually start connecting these wires. I have two wires, and I will check the length to see where they should be placed. And from the looks of it, the shorter one comes on this side. And to place this here, place a washer. Make sure you're not letting these wires run wild into the box once you connected it. If you touch this wire with another cell, that will short circuit the battery, and you'll see some interesting sparks going on. You can notice that on this side it says B-, and that's what you're looking for. Make sure the leads are not touching the aluminum frame around the BMS, and I will be tightening these screws. Alright, so the B- part of this BMS is been tightened. Next I'm going to connect this side right here. These must be twisted a little so they fit in place properly. Alright, that looks solid, guys. So the next step would be to connect the positive lead. Let me see how I drive that. And I will be connecting this to the port first. And I also noticed that this has one side with a larger hole for the front terminal. And now I can connect the lead to the positive side of this battery. I noticed that I had this protection rubber in this kit, so the way you do this is place this on top of this connection. And this gives you extra protection inside the battery. Okay. So we're almost done with the connections here. Make sure there's no nut or screw untightened. Here, and here as well. Right. Now it's time to connect the leads coming from the balancing board to the BMS. We have these two temperature sensors, which I will be mounting on opposite sides of the battery. To fix this in place, I'm going to use some super glue and some Kapton tape to hold it together while the super glue hardens. One is in place. So I will be installing the sensors on each side of the battery. Okay, the temperature sensors are in place now. The last part is adding the on-off switch. So right now, if I press this button, theoretically the battery should turn on. It beeped, and to check if the battery turned on, we can use the multimeter and check the output. You can see that we have power at the P minus, which is the power minus of the battery. So the BMS is functioning properly. I also want to see if the BMS also has Bluetooth, and it actually does have Bluetooth. Focus it. So this is how it looks. Kaptorul pe telefon. Când mă conectez la BMS. So this is how it looks. You can see the voltage of each cell. You can see that we have the MOSFETs for charge on, discharge on. Balance is off actually. The default password of the JK BMS, the one that I'm using, it's 123456. And we can actually see the parameters that we have in the settings. We have cell count number 4, battery capacity 280, balance triggering voltage, that's the difference, calibrating voltage, start balance, okay. And let's see on the control. We have emergency heating, disable temp sensor, we don't want to have that. Display always on, no. Alright, so this shows that we have the battery temp 1 and temp 2 sensors working properly. The average cell voltage is 3.266 volts. And that's all there is to this application. Let's let's move to closing this battery now. I'll do a final inspection, and before closing I want to use some wire ties to hold the temperature sensor wires from moving around. You can see that the top lid also has its own voltage meter. So to connect these, I'm going to stop the battery first. And add these to the main terminals. You can see that the display turns on. It has the voltage and the temperature sensor inside. That's a nice gauge here, but remember you also have the Bluetooth connection, and you can monitor the proper voltage for each cell, and also the right capacity will be shown in that application. So to close this, I will add the screws for the side. So that was it, guys, for assembling this battery right here. It comes with everything you need. It has an on-off switch. It has enough space for 4 cells, 280 amps lithium phosphate, and yeah, it's a great kit. I bought the box separately, and also I found the cells, and I plan to make a group buy. If there will be user interested in this, write me in the comments, and I will try to get a nice deal to get these boxes here in Europe. To get a good deal on this, we have to order at least 10 boxes. You will receive everything you saw in this kit. You'll receive the BMS, the box with all the connectors, all the screws that you need to put this together. And yeah, I like this box a lot. It's compact, it keeps the cells together, and it's everything you need for an RV or other type of camper that uses 12 volts system. I built this for a client that has a 12 volt system on his camper, and he was looking for a more beefy battery. He has a 200 amp hour battery already, but it got quite old, and he said that the capacity is almost half than it was before. So I built this battery for him, and hopefully he will find a good use for it. And yeah, I will keep you guys posted. Also, don't forget to visit deepcyclepower.com and check out the project that started this channel, the Mega Cell Charger. Have a great day, guys, and I will see you on the next video.